Papua New Guinea just produced its first submarine volcanic eruption in more than 50 years, and scientists still do not know exactly what is erupting. The footage from space is striking. An ash plume 4 kilometers into the atmosphere. A thermal anomaly across 7 square kilometers of ocean. A plume of discolored water 9 by 11 kilometers. 2 volcanic vents 2.5 kilometers apart. A steam column 3,000 meters above the water. This is no longer a brief seismic disturbance. This is a submarine volcanic system that is rising toward the surface. But here is the detail that tells the real story. The footage the world is now watching was not captured by a fisherman with a phone. There are no tourists 125 kilometers southeast of Manus Island. The footage came from 5 different satellites. A new volcanic landform may be trying to push through the surface. Kennedy Masses has fished in these waters for 12 years. He saw smoke coming out of the sea. He told the ABC, "It sounds like thunder and the sea smells like metal burning." The next morning, the reef looked like a boiling spring. Dead fish on the surface. Steve Saunders at the Rabaul Volcano Observatory called it a rare event worldwide. The central Bismarck Sea vent last erupted in 1972, for 4 days. Then it went silent. For 54 years, the seafloor held still. On day 1 of its return, the steam column was already 3 kilometers tall. On day 13, the steam is still rising. And no one yet knows how shallow the vent has become. This is how it began. On the 31st of March, 2026, a single earthquake registered under a patch of empty ocean 125 kilometers southeast of Manus Island. The Rabaul Volcano Observatory logged it. No surface signal followed. On the 25th of April, the same patch produced a second earthquake. Same depth, same location, same silence. Then on the 8th of May, the ground beneath the Bismarck Sea released a swarm. 6 earthquakes inside a single day. Within hours, NASA's Aqua and Terra satellites detected the first signature, a white, steam-rich plume rising from open ocean. By May 10th, the steam column had climbed 3,000 meters. By May 11th, Landsat 9 caught 2 plumes from the same growing underwater platform. By May 12th, VYRS detected the thermal anomaly, and DAVAAC issued its first ash advisory. By May 15th, MODIS was tracking pumice rafts in green, discolored water. On May 21st, NASA's Earth Observatory published its image of the day. Jim Garvin, chief scientist at NASA's Goddard Space Flight Center, summarized, "Eagerly waiting to see if a new island is about to be born." Here is what makes this eruption different from anything on land. The magma-feeding Titan Ridge is basalt, the kind that forms at a back arc spreading center, where seafloor segments are pulled apart and mantle rises through the fractures. These basalts carry between 1 and 1.5% water by weight. They erupt at 1,100 to 1,200 degrees Celsius, 2,000 to 2,200 degrees Fahrenheit, hot enough to flash seawater into steam in fractions of a second, hot enough that the thermal signature reaches a satellite in low Earth orbit, hot enough that the metal smell Masses described is sulfur and iron boiling off the basalt faster than the ocean can absorb. Simon Carn, a volcanologist at Michigan Tech, reads the thermal data as evidence the vent is much shallower than what's implied by the existing bathymetry. The maps show several hundred meters of water above it. The signature says much less. This is the chemistry that built Surtsey. Off Iceland in 1963, a fishing crew watched a column of ash break the surface within 4 hours. 3.5 years later, Surtsey was a permanent island. Hunga Tonga in 2022 was the same family of eruption, but on a subduction zone stratovolcano with a pressurized magma chamber. Titan Ridge sits on a spreading ridge. Less pressure, less explosive. So far. To understand what is happening underneath, look at where the seafloor is pulling apart. The Bismarck Sea sits between 2 microplates, North and South Bismarck. The boundary between them, the Bismarck Sea Seismic Lineation, is a chain of transform faults and spreading segments. Titan Ridge sits inside it. GPS measurements clock the Manus Basin opening at 137 millimeters per year, 13.7 centimeters of fresh seafloor every year, one of the fastest spreading rates on Earth. Every centimeter pulled apart has to be filled. Basaltic magma rises from the mantle. Some stays in chambers, some leaks, some breaks the seafloor and erupts. The satellites tell scientists where the eruption is, not how deep the magma chamber is, not where the next fracture will open. The bathymetric record here is based on decades-old sonar passes that cannot resolve the active vents. The deep ocean floor is mapped at lower resolution than the surface of Mars. The eruption being broadcast from space is not the main event. It is the safety valve. The question is whether the valve is large enough to handle magma that has been loading underneath this section since 1972. Because the last time a volcanic edifice in this sea reached the limit of what its base could support, the result was not an island being born. The result was a mountain falling into the ocean. Here is what is not making most headlines. There is an island in the Bismarck Sea called Ritter. It used to be a mountain. Before that morning, Ritter Island was a steep-sided volcanic cone, 780 meters tall, 2,560 feet, recognizable to every sailor in the Dampier Strait. On the morning of March 13, 1888, the western flank pulled away from itself. There was no warning. A sector of the cone, roughly 2.4 cubic kilometers, larger than the collapse at Mount Saint Helens in 1980, slid off the volcano and into the ocean. The water on top of it had to go somewhere. Wave run-ups of 12 to 15 meters, 40 to 50 feet, struck the islands of Umboy and Sakar. Every village along the strait between them was demolished. The village of Lutherhafen on northwestern Umboy was abandoned and never rebuilt. Tide gauges in Sydney recorded the wave. In Arica, on the coast of Chile, newspapers reported ships smashed and capsized. The wave had crossed the Pacific. Between 1,500 and 3,000 people died. After the collapse, the mountain that had been 780 meters tall was 140 meters tall, a crescent-shaped remnant of the cone. That crescent still sits in the Bismarck Sea today, 138 years later, sticking out of the water as the only visible record of the mountain that used to be there. In 1972, the same year a vent erupted in the central Bismarck Sea 16 kilometers northwest of where Titan Ridge is now growing, Ritter erupted again. Both went quiet that year. 54 years later, one of them has come back. The same sea that took Ritter. The same plate boundary. The same kind of question being asked again, 138 years later. And it is still not over. NASA's monitoring continues. The Darwin Ash Advisory is still active. Scientists are watching for the first sign of something solid breaking the surface. The question now is not whether the eruption will continue. It already has. The question is not whether the vent is shallow. It already is. The question is whether the people who live downwind, downcurrent, and downstream of an unmapped seafloor are paying attention to the same satellite footage the world just watched. The crescent that remains of Ritter Island still sits in the Bismarck Sea, 138 years later, as a record of what used to be a mountain. The only thing that has changed since 1888 is the number of people who live close enough to die if it happened again. If this story is worth telling, subscribe. We cover more of these every week.